let us begin the last topic of this chapter, and which is very much important as far as examination is concerned and the application of the Laplace transformation is concerned. This topic deals with the solution of the differential equation by using Laplace transformation. So, this is the solution of ordinary differential equation by using Laplace transformation. In exam, one example of 7 marks will definitely be asked. Now here you are given one differential equation, say a2 say d square y by dx square plus say some a1 dy by dx plus a0 y equal to some function g of t. And here you are given condition also, say subject to y at some point t0 is y0 and y dash at some point t0 is say y1. So these are the condition also given, so that's called the initial value problem. Okay, this is called the initial value problem. Now see how to solve by using Laplace transformation. So let Laplace transformation of y of t equal to say y of s, and therefore inverse Laplace transform of y of s is y of t. Okay, now this is the equation. So these are the steps like this. The first step is apply Laplace transform on both sides. Okay, so apply Laplace transformation on both sides of 1. So we can apply the Laplace transformation on both sides on the 1. Then you need to use the formula like this. See, Laplace transformation of y of t equal to y of s, Laplace transformation of y dash t equal to s ys minus y at 0 Laplace transform of y double dash t is s square ys minus s y0 minus y dash 0. Do take care here, this y dash is the function y of t, and the capital letter Y is the Laplace transform of y of t. So that care must be taken. Okay, so the next step would be, so the first step is apply both sides Laplace transformation. Then the second step is, so for that we need to use we need to use this formula, and next step is solve the equation for ys. So we need to make the ys as monitor, and we need to solve that equation. We will see in the example. Then we need to apply inverse Laplace transform on both the sides, and then finally find y of t. That is our answer. Okay. So this is the way we can solve the examples of the differential equation by using the Laplace transform. Let us take one example now. So let us begin this simple example that was asked in GTU summer 15. So the example is like this: solve y dash minus 4y equal to 2 e power 2t plus e power 4t, given that y at 0 equal to 0. Now what we are given is y dash minus 4y equal to 2 e power 2t plus e power 4t. Okay. Now the first step is apply Laplace transform on both sides. So take Laplace transform on both sides. So then we are having Laplace transformation of y dash minus 4 Laplace transformation of y equal to 2 Laplace transform of e power 2t plus Laplace transformation of e power 4t. We have used the linearity also. We have used the linearity of Laplace transformation. Okay. Now what is the Laplace transformation of y dash? So Laplace transformation of y dash is sys minus y0. So this is s ys minus y0. Laplace transform of yt equal to ys. So this is L Laplace transform of y dash. So this is sys minus y0 minus 4 Laplace transformation of y is ys equal to 2 Laplace transformation of e power 2t. This is standard formula. Now you should remember 1 over s minus 2 plus this is 1 over s minus 4. Now what is the next step? Next step is apply solve the equation for ys. So we need to make the ys as the monitor. So therefore, and we need to use the y at 0 equal to 0 also. So here we can put y at 0 equal to 0. So and these two we take together. So that is nothing but s minus 4 ys. This is 0, y at 0 is 0, that is given, and that is equal to 2 upon s minus 2 plus 1 over s minus 4, and therefore ys is equal to 2 over s minus 2 s minus 4. This s minus 4 you can take it now on this side plus 1 over s minus 4 square. Now this can be made partially fraction like 1 over s minus 2 s minus 4. So you can have a over s minus 2 plus b over s minus 4. So this is 1 equal to a into s minus 4 plus b into s minus 2. So if I take s to be 2, then this is 1 equal to a into minus 2. So a minus 1 by 2. This is the part of your example. You should write in the paper also. Put s is equal to 4, 1 equal to b, 4 minus 2. So b equal to 1 by 2. So here 2 is there, that we have not taken. So that you should take care. So this is 2 a over s minus 2, a is minus 1 by 2 over s minus 2 plus b over s minus 4. So plus 1 by 2, 1 upon s minus 4 plus 1 over s minus 4 square. So therefore ys is equal to, now these two to cancel. So I write this first, 1 over s minus 4, then minus 1 over s minus 2 plus 1 over s minus 4 square. So this is the third step, solve for ys. Okay, and now apply inverse Laplace transform on both sides. So apply inverse Laplace transform on both sides. So we get like this, inverse Laplace transform of ys equal to inverse Laplace transform of 1 over s minus 4 minus inverse Laplace transform of 1 over s minus 2 and plus inverse Laplace transform of 1 over s minus 4 square. Now what is the inverse Laplace transform of 1 over s minus a? It is e power at. So this is equal to, now what is inverse Laplace transform of ys? So that is y of t, and this is e power 4t minus e power 2t. And now we know the inverse Laplace transform of 1 over s power n is equal s power say n plus 1 is equal to t to the power n over n factorial if n is our natural number. And so by applying first shifting theorem, 1 over s minus a power n plus 1 equal to e power at t power n over n factorial. So this is now plus 1 over s minus 4 squared. So this is e power 4t into t power n upon n factorial. Here n plus 1 is 2. So n is 1. So this is t. So this is our answer and final solution of the differential equation. Okay. Next let us take the example. Okay, this was asked in GTU summer 18, winter 18. The question is solve y double dash, that means second order derivative, plus 2y dash plus y equal to e power minus t, where y at 0 equal to minus 1, y dash 0 equal to 1. Now, so here we are having y second derivative plus 2y derivative plus y equal to e power minus t. So, we take Laplace transform on both sides. So, therefore, Laplace transformation of y second derivative plus 2 Laplace transform of y derivative plus Laplace transformation of y equal to Laplace transformation of e power minus t. Now, see the Laplace transformation of y second derivative, and Laplace transformation of y second derivative is s square ys. So, you need to remember that formula, s square ys minus s y at 0 minus y dash at 0. So, this is the Laplace transformation of y second derivative plus 2 Laplace transformation of y dash. Now, Laplace transformation of y dash is s ys minus y at 0. So, s ys minus y at 0, but that 2 is there. So, 2 y at 0. So, that 2 you should write. So, this is s ys minus y at 0 plus Laplace transformation of y is ys, and Laplace transformation of e power minus t is 1 upon s plus 1. Okay, so this you need to do. Now, here we are given y at 0 minus 1, y dash 0 1. So, this we need to apply here. So, this is s square, and take this ys out common, then plus 2s plus 1 ys minus s. Now, y at 0 is minus 1, y dash 0 is 1, then minus 2, y at 0 is minus 1 and is equal to 1 over s plus 1. This is s plus 1 square ys is equal to minus this is plus s, this is a minus 1 and this is plus 2. So, this is minus 1 plus 2 equal to 1 over s plus 1. So, therefore, s plus 1 square of ys, and that is equal to 1 over s plus 1. Then this s on the right side, so it is minus s, and this is plus 1 on right side is minus 1. And so, this is nothing but s plus 1 square ys equal to 1 over s plus 1. We can write minus s plus 1. Therefore, this ys is equal to 1 over s plus 1 cube and minus this s plus 1 over s plus 1 square. So, minus 1 over s plus 1. Okay. Now, so this is the next step, that is solve for ys. Okay. So, we have solved for ys. So, now we need to take the inverse Laplace transform on both sides. So, apply or take inverse Laplace transform on both sides. So we get inverse Laplace transform of ys equal to inverse Laplace transform of 1 upon s plus 1 cube minus inverse Laplace transform of 1 over s plus 1. Just we have seen inverse Laplace transformation of 1 over s minus a equal to e power at. Inverse Laplace transform of s minus a power n plus 1 equal to t e power at and t power n upon n factorial. Okay. So this is equal to s plus 1 cube. So s plus 1 cube. So this is e power minus t square upon 2 factorial. So that is 2 and minus inverse Laplace transform of s plus 1. So this is e power minus t. So that is the answer. And this you must write inverse Laplace transform of is is nothing but y of t. Okay. Let us take one more example. This was asked in GTU summer 15, winter 16, summer 18. The question is solve by using Laplace transform y second derivative plus y equal to sin 2t with y at 0 equal to 2, y dash at 0 equal to 1. So here we are having y second derivative plus y equal to sin 2t. Take Laplace transform on both sides. So then we are having Laplace transformation of y second derivative plus Laplace transformation of y equal to Laplace transformation of sin 2t. Now Laplace transformation of y second derivative is s square ys minus s y at 0 minus y dash 0. Remember this formula. Plus Laplace transformation of y is ys and equal to now the Laplace transformation of sin 2t. So that is a upon s square plus a square. So 2 upon s square plus 4. Now we can take these two. So this is s square plus 1 ys minus s. Now y at 0 equal to 2 and y dash at 0 equal to 1 equal to 2 over s square plus 4. So y dash at 0 equal to 1 and y at 0 equal to 2. So now this is equal to s square plus 1 ys is equal to 2 over s square plus 4 plus 2s plus 1. So therefore ys equal to 2 over, so now we take this s square plus 1 on this side. So 2 over s square plus 1 s square plus 4 plus 2 s over s square plus 1 plus 1 over s square plus 1. We need to take care of the things that inverse Laplace transform we can find easily. Now this is not difficult to handle. 1 upon s square plus 1 s square plus 4, this can be written as like this. Adjust, you can easily adjust that part, that s square plus 1 s square plus 4, and if I write minus sign here, then this is s square plus 4 minus s square minus 1, so that will be 3. Okay, so I need to divide by 3 here. Okay, that is easy. Or you can make it a upon s square plus 1 plus b upon s square plus 4, that is also not a problem. So this is equal to 2 by 3 1 upon s square plus 1 minus 2 by 3 1 upon s square plus 4 plus 2 s upon s square plus 1 plus 1 upon s square plus 1. Now this you should make it together. 2 by 3 1 upon s square plus 1 plus 1 time 1 upon s square plus 1. So this is 2 by 3 plus 1, and so this is nothing but 5 by 3 1 over s square plus 1 minus 2 by 3 1 over s square plus 4 plus 2 s over s square plus 1. Now we take inverse Laplace transform on both sides. So apply inverse Laplace transform on both sides. So that is inverse Laplace transform of ys equal to 5 by 3 inverse Laplace transform of 1 over s square plus 1 minus 2 by 3 inverse Laplace transform of 1 upon s square plus 4 plus 2 inverse Laplace transform of s over s square plus 1. This is y of t. Now these are the very standard function. 5 by 3, this is sin t. This is minus 2 by 3 1 upon 2 sin 2t, and this is plus 2 cosine t. Okay, so the answer is y of t equal to 5 by 3 sin t minus 1 by 3 sin 2t plus 2 cosine t. Okay, so that is one example on that. Okay, we stop here. Next we shall take 2-3 more examples and we finish the chapter.